Okay, looks like we are live. All right, I'm looking at the chapter. Let's kill the debugger. Okay, chapter one. Way too much of screens for this. Okay. Now, let's look at the what the description says. I mean, I did go through all of this, so maybe I am not gonna spend too much time on this. Um, you may have to do your chapter one on your own. Essentially, they specify a tile language which can work on tensors. Tensors from TensorFlow does things like matrix multiplication, transpose, whatever. I mean, it doesn't do it, but that's what we want to do. Mm, like create a language that can do that. And also do automatic shape inference. We don't have too many types. We are just gonna use floating point 64 f64, and yeah, you should be able to have functions and call them. Uh, that's about it. The first tutorial is about like parsing, the lexer and parser for Thai language. Um, if you haven't gone through LLVM Kaleidoscope tutorial, I would highly recommend going through it. That's a good starter on how to write a lexer and parser. There is not too much information here, but yeah, it's mostly like there is similar lexer and parser. So as you can see in the AST of this above code, which is there is a multiply transpose function. You do transpose of A, transpose of B, and you return. Um, so yeah, let's see the equivalent of here, right? So that's inside a module. So a top level file is converted into a module, and you have a function. Um, and inside a function, there is a proto, which uh, which essentially is an AST um, for function definition. So um, function definition has both function declaration and function body. Um, you can also have just declarations sometimes, right? So that's why we kind of split uh, function declaration into proto and body. So as you can see, proto, the name is multiply transpose. There is location information, which at is usually for location transformation. In MLR it looks like. And then um, you have parameters that you are passing to the function A and B. Um, it's not saying what types it is because we haven't checked the types or anything like that. It's just parsing and creating an AST. And then inside the function body, we have something called block, because um, it can have multiple expressions within the body. So we'll have a block and we'll have like a group of operations that we are gonna call. So block has a return, um, a return AST, but before it does that, I guess it's trying to say inside that return, it's trying to evaluate this. Essentially, it's gonna do a binary operation of star, which is nothing but multiply, and that's at this location, uh, is what it is saying. And it's gonna call a transpose on variable A, call transpose on variable b, and that's gonna be multiplied, and that in turn is gonna be returned. That's about it. And if you see main, which is over here, we have declared a variable assigned with a value. We haven't specified the shape of the tensor, but we do have like angular. We have brackets here or braces. So shape of S should be automatically inferred based on that. That is one of the language feature. Mm, and in this case, this is a const. This is of different shape. So we need to do shape conversions when needed. So B would be 2 by 3 matrix, not 1 by 6 matrix as shown here. And then you are calling multiply transpose on A and B, and you have variable C that is assigned with that. These three are essentially similar functions, so let's not worry too much. Let's just go ahead and look the AST for the main, AST dump for the main. So you have function, proto, name is main, param, uh, there are no parameters for main, and block. mm, Block has a variable decal a, which doesn't have shape here, and the uh, the tensor here, literal tensor, got uh, converted into literal node, literal AST node, and that's what we are seeing. There is variable decal b, which is shape and whatever. And then um, the size, the shape of this is specified here, and you can see that shape of um, this particular tensor is specified here as 3 and as 3 here. That's interesting. So you need to do that while parsing, I guess. So when you see a bracket and based on how many numbers you see, you kind of append this, maybe. I don't know. Or just like you keep track of count. You keep track of, oh, I guess instead of saying 1 comma 3, they just said 3 here. Interesting choice. And it's a little bit inconsistent with this, but is it really? I don't know. Let's see. Here we are calling multiply transpose. Um, Multiply transpose, and yeah, it takes var A and var B. Similarly, rest of the things, and then you have block and whatever. So now let's go look at some places like this. Where are they actually? How the literal AST is being created? Let's go look at that. That's interesting to me. This is the code. toyc.cpp is the main uh, file. Um, and we have include directory where we have ast.h where we define all the different types of ASTs. Um, and lexer essentially like goes through the toy language file that you might have created, and then goes line by line, and tokenizes them. Tokenizes essentially means like it understands what each word is, what it is, in the sense if we go to if we take an example, right? Def means starting of a function. So it knows it's a function AST node. So it's gonna return a token saying it's a def type of token, and then we're gonna do parse. Uh, we parse it accordingly. Um, I guess. Let's see. Mm, that's what lexer does. It essentially goes through the file line by line. For example, when it says this thing, it needs to find out. It needs to say that it is a literal, and in this case, it's a numeric value or whatsoever, right? So that's what it needs to say. And here, when you call this, it needs to say that it's a variable, and then um, multiply transpose. Is it a variable? No. I think it's a call expression, right? What are the different types of tokens? We'll go through that. The different type of tokens that. So, for example, we have semicolon, parenthesis open, close, bracket open, close, square bracket open, close, end of the file, and we have return, where you have like return statements. Sorry, there is a variable token type. There is a definition, starting of a definition, identifier and number. Identifier is essentially something that a variable that you might have defined or a function that you might have defined. Uh, so those two things are usually the ones that will go on identifier. Um, Apparently, they are called primary tokens, and these things are called commands, which is essentially return variable definition. Hmm. Okay, that's what lexer is doing. What is parser doing, right? Parser is this is a simple recursive parser for Thai language. It produces a well-formed AST from a stream of token supplied by lexer. No semantic checks or symbol resolution is performed. For example, variables are referenced by string and code could reference an undeclared variable and the parsing succeeds. Yeah, so parser essentially gives out AST. And now what is this parser ast.cpp file doing, right? Mm, this files implements AST dump for Thai language. So we have parser, we have AST defined, but in AST we have like a dump method defined for each AST node. For example, there is module AST and you have dump method defined, and you have function AST and you have dump method defined. No, you don't. That's interesting. So I guess we only defined for module because finally we would have parsed the whole module. Oh, that's actually not part of module. It's a separate thing. But it takes module AST as input and it will dump the whole thing. So let's see the implementation of this. Mm, so it's gonna take an AST module, reference to AST module. So what it is doing is it's creating an object of AST dumper, and it's calling dump on that particular AST node. So what is this doing, right? AST dumper. Let's go check out where this is defined. So helper class that implements AST tree traversal and prints the nodes along the way. The only data member is the current indentation level. Yeah, so this AST.cpp is what was like cleanly printing um, all of these things for us, like with indentation and everything, um, starting from the top of the AST tree, which is module, ouch, um, yeah, to the, yeah, like lowest child nodes, leaf level nodes. Ah, okay. Hmm. So you can see dump method is defined for all of them. I guess like dump of module st is nothing but um, in module st you'll have if we go look at module st definition, we'll have like a vector of functions, and you just go check each function and dump the ast for that. That's what you do. Mm, so that's module ast is nothing but a collection of function ast nodes. Now, if we go look at the function ast, right? Which we, each function will ast will have like proto and body. So um, let's go back and look the dump for function ast, right? Dump implementation for function ast. So you're gonna just do dump on proto and body. That's about it. So if you go look at dump on um, not this, dump on proto. So you can see that it is printing LLM errors is just like think of it as a C out or printf. It's just a way of printing things to the console. So yeah, so we are printing proto, we are printing a tick, and then saying node.get name, which would give the function name, and then lock location. We would have gotten location um, from the lexer to the to create the AST node, and then here we can just print the location. Mm. Yeah, this is the neat thing. So if you haven't used indentation to print a tree, this is probably a good way. You can just indent, and it has a static indentation, not static, I guess, is it? Yeah. It has this current indent, and like each time you call it, it's gonna increase it increase it by one, and each time you come out, it's gonna reduce the indentation level, and then you get this nice yeah, for example, yeah, here you can see the destructor is reducing the level, constructor will increase the level, and so that's a sidetrack. But yeah, what are we doing? We are printing the parameters, which is stored as arguments, and then um, that's okay. I mean, this is all okay. You have AST, dumper, whatever, right? Wrote that. So finally, in our main module, we'll parse the input dot toy file, create a module AST, and call dump on module AST. That's about it. Um, yeah, pretty simple, pretty neat. Yeah, I'm gonna jump to chapter 2. Um, but if you haven't mm, like gone through, if you haven't, if you're not familiar, I would recommend taking your time and going through chapter 1. Yeah, understand like what lexer means, what parser means, and what AST means. And those three concepts are sufficient for us to get to the next chapter. So we could dot dot chapter 2. Let's go to chapter 2. Oh, just code. So, not that, dude. Create a launch.json file for CPVs, and let's look at launch.json here. Yeah, it should be something like this. I'm just setting up my debugger. Okay, first let's go through the chapter 2 uh, readmes, or yeah, what are we doing here? Let's take a pause for a little bit and start the stream again, maybe with chapter 2. Yeah, be able to reconnect. Your stream will stop and you'll no longer be live. Can I pause it?